So what are complex numbers? Complex numbers are also known as imaginary numbers. And they have great many applications in math. Now, once we use a complex number, there are other operations which would actually result in a real numbered value. They show up constantly when we deal with radicals. For example, suppose we want to find the square root of -9. Your calculator will not be able to give you the answer for square root of -9. The reason being, you can't take the square root of a negative number. By all means, you can't take the square root or an even root of a negative number. So when we have a root of a negative number, not necessarily a square root, it could be the fourth root, fifth root, doesn't matter. We have to represent it using a negative number, an imaginary number, because there are circumstances in maths when we would have to deal with the square root of a negative number. So, square root of -9, I can write it as square root of -1 times square root of 9. The square root of 9 part is very easy. It's just 3. The square root of -1 part, we will represent that using the letter I. So I would end up having 3 multiplied by I. Or you can also write it as I multiplied by 3. It doesn't matter. So the letter I refers to a complex number. Anytime you see I in an expression, that would make the expression complex. So square root of -1 is I, which would simply mean if I square on both sides, square root of -1 would be equal to I squared. The root and the square will get cancelled. So I squared would be equal to -1. So what we know is I is square root of -1. I squared is just -1. All we need to know is these two relations. I equals square root of -1 and I squared equals -1. We can pretty much write I raised a different power using these two relations. The standard notation for a complex number is A plus I multiplied by B. So here, A is called the real part and B is called the imaginary part. The reason being, if A is 0, if B is 0, I'll call that the number C. C would just be equal to A. There is no imaginary part, so the number becomes a real number, which is why we call it the real part. If A becomes 0, then C is I times B, purely complex or imaginary. it has no real part. Hence, we call the b as the imaginary part of the complex number. So the general notation of a complex number is a plus I multiplied by b. So as an example, let's take square root of negative 81. I can write this as square root of negative 1 times square root of 81. Square root of negative 1 is I multiplied by square root of 81. Square root of 81 is 9, so the answer is I9 or 9i. The real part of square root of negative 81 is 0. The reason being, I can write I9 as 0 plus I times 9. So the real part is 0 and the imaginary part is 9. What we have here is square root of negative 100. I can write this as square root of negative 1 times square root of 100. Square root of negative 1 is I multiplied by square root of 100 is just 10. So I can write this as 0 plus I multiplied by 10. So the real part is 0 and the imaginary part is 10. And that is the complex number notation of square root of negative 100. Here we want to multiply square root of 18 with square root of minus 2 and then simplify. So we will have square root of 18 times negative 2, which would be square root of negative 36. Now I can split it up and write it as square root of negative 1 times square root of 36. And square root of 36 is simply 6. So we will simply have I times 6 as the answer. So here we have 0 plus I times 6. The real part is 0 and the imaginary part is 6. Suppose we have two complex numbers, 5 plus 2i and 3 minus I. We're going to treat this addition very similar to what we do usually in terms of grouping terms together. 5 plus 2i, I'm adding 3 minus I. I'm going to bring the numbers together, so 5 plus 3, and the I terms together, 2i minus I. 8, 2i minus I is just I. So I end up getting 8 plus I as the answer. Okay, so 11 minus I plus 6 plus 5i, or I times 5, they are one and the same. I'm going to add the numbers together and then add the imaginary parts together. So the numbers 11 plus 6 would give me 17. 5i minus I is 4i, or I times 4, one and the same. So the answer is 17 plus 4i. The process of multiplying two complex numbers is very similar to multiplying factors, foiling. So here I have 3 plus 2i multiplied by 3 plus 2i. So I'm going to FOIL 3 times 3, which is 3 squared, 3 times 2i, plus 2i times 3, plus 2 times 2 is 4, and I times I is I squared. 3 squared is 9, plus 6i, plus 6i, plus 4. Earlier, I mentioned that I squared is -1. So I'm going to put -1. So 9 plus 12i minus 4. 9 minus 4 is 5. So the answer is 9 plus 12i, which is the same as saying 5 plus 12i, which is the same as saying 5 plus I multiplied by 12. So to multiply I plus 4 and 2 minus I, we do the same foiling process. I times 2, 2i, minus I times I, plus 4 times 2, 8, minus 4 times I. So 2i minus I squared, plus 8 minus 4i. 2i minus I squared is -1, plus 8 minus 4i. So 2i plus 1 plus 8 minus 4i. So 9, 8 plus 1 is 9. 2i minus 4i is minus 2i. Multiplying two complex numbers and writing it in the form a plus ib is pretty straightforward, especially if you know how to distribute terms and factors. But writing or dividing a number by a complex number, or a complex number by a complex number, and writing the answer in the form a plus ib is tricky. So suppose I have 9 over 2 plus I. The idea here is to use something similar to rationalization with radicals. So the complex conjugate of a plus ib is a minus ib, and vice versa. So a plus ib and a minus ib are conjugates of each other. So if I want to divide 9 by 2 plus I and write it in the form a plus ib, I simply have to multiply and divide by the conjugate that's in the denominator, conjugate of the term that's in the denominator. So I multiply and divide by 2 minus I over 2 minus I. So 9 times 2 minus I divided by 2 plus I times 2 minus I. Distribute the 9. 9 times 2, 18. 9 times I minus 9i. Denominator, we have the form a plus b, a minus b, which simply is a squared plus b squared. Excuse me, a squared minus b squared. So we have 2 squared minus b is I squared. So 18 minus 9i divided by 4 minus of minus 1. 18 minus 9i divided by 5. Now, we don't even have to do this part from here to there. Anytime you multiply a complex number by its conjugate, the answer is always a squared plus b squared. Just like how a plus b times a minus b equals a squared minus b squared, a plus ib times a minus ib is a squared plus b squared. In other words, you simply have to square the real part and add it to the square of the imaginary part. And that's exactly what I did up here. The real part of 2 plus I is 2. The imaginary part of 2 plus I is 1. So 2 squared plus 1 squared is 5. Finally, I can write the answer as, 18 over 5 minus I 9 over 5. Since I have a common denominator of 5, I'm just splitting the numerators and I write it as 18 over 5 minus I multiplied by 9 over 5. So the real part is 18 over 5. The imaginary part is negative 9 over 5. So the conjugate of plus I is minus I. So multiply and divide by the conjugate. So minus I over minus I. So we would have 3 times I, negative 3i, divided by I times negative I. The negatives would go away. So I will have 3i divided by I times I squared. But I squared is negative 1, so 3i over negative 1, which is simply negative 3i, or 0 minus I multiplied by 3. So the imaginary part is negative 3, and the real part is 0.